This is probably the most important video of this section, okay? It's about how do you put it all together? Just like in chapter 1, we had so many different ways of calculating integrals, and there will be more in chapter 3, and you have to be able to just tell at a glance what you want to try. And maybe you won't choose right, and then you'll try something else. This is the same idea. When I ask you about volume questions, I'm not going to tell you what to use. I just need you to find the volume. So being able to say, well, let's try the volume this way, look at it and say, maybe let's try the volume a different way, is a good skill to have. So I want you thinking through this section, when is it going to be easier to use one? When is it going to be easier to use the other? In this video, I'm going to show you both, and we're going to look for patterns. If you can identify those patterns, it'll make you more adept. I think, do you say adept as a noun and adept as the adjective? I don't know. It doesn't matter. But that's my goal for this video. Now, the book has this table that I wanted to love. I really wanted to love this table. It's giving a nice comparison. And if you want this is in 2.3. If you want this, go for it. I don't think it's very helpful, personally. I don't find this useful to me. And again, I use textbooks when I teach, not just like to give myself content for the videos and notes and inspiration. I forget things all the time, and this does not help me remember. But if it helps you, use it, okay? I think for me, the main things, there's two things that I want you to think about that help me. Okay, these are questions you have to ask yourself. Is it easier to use the same variable as the axis? So again, use x for x-axis, use y for revolving around y-axis. And that's going to be the disk method. Or is it easier to use the different one? That'll be shell. Rotating about the x-axis for disk, you need things in terms of x. Rotating about the x-axis with shell, it needs to be in terms of y. That's one question to ask. And the second question is the question of multiple regions. Whoa, not multiples. Multiple regions. We looked at that at the very, very, very beginning, right? If we're using the disk method here, we have to split this into two regions. We have two integrals, which is no good. But if we're using the shell method, we can just use one of these guys, and that's just going to be g minus f. And then we get this shell like that. Okay, so shell method is going to be nicer here. And that's one of the things with multiple regions. And again, to kind of put the first question back at you, we already have these in terms of y, and we're rotating it about the x-axis. So that's another thing that makes it nicer looking to set things up with the shell method. So that'll bring us into our last example of this section. Example 5. Not 4 like my notes. Set up an integral using both methods. All right. Well, that looks like I hybridized a T and an H. That's kind of cool. I'm sure that's some kind of band logo. I'll start a band. We'll call them the... No, I don't have a band name. I still can't smile completely normally from that surgery, but it's getting better. Okay, so let's do part A. So we got one function. You know what? I'm going to do this right. We got one function. This is y equals x. And we got another function. That's going to be y equals 2 minus x. We're looking at this region between them, and we're rotating about the x-axis. So before we set this up, things to look for. First off, Is it easier to have this in terms of x or terms of y? I would say it's easier to have this in terms of x. We're already solved for y. Having it in terms of x is easier, so that makes you think disk method. But it wouldn't be bad to solve for x here. This is already solved for x, and this is super easy to solve for x. So having things in terms of y would be fine. So far, shell and disk method both look good. The second question is, are you going to have multiple regions? Well, if you use the disk method, what do our rectangles look like? Disk method is all about rotating this disk, rotating this about, like, wait, I forgot how to draw this picture. It's like, it's this circle. Oh, so we're going to have to use one circle for this guy and another circle when we get over here. So there's going to be multiple regions if we use the disk method. Whereas if we use the shell method, what does our thing look like for shell method? Well, shell method, this will be one of our rectangles. It'll be blue minus red. And we revolve it like this. Oh, okay, we can do this in a single. It's always blue minus red if it's a shell method. So I think shell method will be a little easier. Let's set them both up. And we'll use Desmos and make sure they're the same answers. So if we use shell, we're going to say volume is 2 pi. Okay. We're rotating it about the x-axis, so things need to be in terms of y. This is 2. This is the point 1, 1. The y is going from 0 up to 2. And the shell method says, okay, we're rotating about the x-axis. So it's just going to be a y value here for the height, the radius. The y value here is just y times the height. Again, you can draw out that picture. I think that picture can really help looking at this. But the height's going to be blue minus green. Again, in terms of y. The blue, in terms of y, is going to be add x, subtract 2. X is actually also 2 minus y. So it's blue minus red. And this is our integral. We can clean this up a little bit. 0 to 1 of y times 2 minus 2y. You could clean it up some more, but we don't need to. That's not the point of this video. Whereas if you use the disk method, right, you're going to have to use 2 regions for the disk method. The first one, OE pi times integral. Now it's rotating about the x-axis. So we use x's. 0 to 1 of the red function squared. Because remember, these are all circles. Pi times the radius squared is that area of that cross-section circle. Dx plus pi times the integral from 1 to 2 of the other one. 2 minus x squared dx. Kind of ran out of room. And again, it's not bad, but you're going to have to FOIL or do a U substitution. You're going to have 2 integrals. And these integrals aren't hard, but I hate definite integrals. You've seen how many mistakes I make when I evaluate definite integrals. The fewer definite integrals I can do, the happier I'm going to be. So I think shell's the winner here. But again, you can use both. You can use either. And again, one thing that I really want to always recommend you do is check your answer. Now, hopefully, you should have the same ones. Y going from 0 to 1 of just y times, it was 2 minus y dy. Was this the integral? Oh, 2 minus 2y, because we had to subtract the functions. Wait, all right, it does change it. That was our shell method. The other one was pi times the integral from 0 to 1. Whoa, that's not right. Of just x squared dx plus pi times the integral from 1 to 2. Wait, did I write 1 to 2? I did. Of 2 minus x squared dx Same volume. Let's do another one. Part B. Let's say we're looking at some sort of parabola. Very similar to what we've done before. Rotating it about the x-axis again. This is a parabola y equals 4x minus x squared. We'll ask ourselves the same two questions that we did before. Is this easier in terms of one variable or the other? And are we going to have to worry about multiple regions? Well, right off the bat, multiple regions is not something we have to worry about. There's only one function here, and it doesn't cross any axis. So the second question doesn't matter. Just what variable do we want to integrate with respect to? So if we use the disk method, we need things in terms of x. Good. We already have that. If we use the shell method, we need things in terms of y, because we're rotating about the x-axis. Disk method, the same letter. X-axis in terms of x. That's the disk method, whereas the shell method is the opposite. Getting this solved for x, getting this in terms of y, is not easy. It's going to require us to split things up twice. So I'm not even going to write the shell method for this one. Let's just do the disk method. And again, disk method says that we just look at, each one of these is a disk. It's pi times the radius squared is the area of this disk, and we add them all up. So, disk method, pi integral, x is going from 0 to 4, and we're using x's, of the height, or the radius, squared. This one's the clear winner in this one. You can do this with the shell method, but it's not worth it for me to do it right now. It's going to spend a lot of time. Be a good challenge problem for any of you, though, if you want to challenge yourself. This next one I made up, and I think it works as a good example. But we're going to find out if it doesn't. All right. So it's going to look kind of like a square root function, but it's not. This is the point e comma 1. And we're looking at the function y equals the square root of the natural log of x. And we're looking at this region right here, again, rotated about the x-axis. So it's one region, no matter which method we use. And, well, we could solve it it's already solved for x, so disk method seems easier. But it wouldn't be hard to solve for y either. Just square root and then square both sides and then take the exponential of both sides. So it doesn't seem immediately clear which one's better. So let's do both. The shell method. Again, shell, it's in terms of, it's rotated about the x-axis. So we're going to think about things in terms of y. These are, let's use a different color. These are our shells. They're getting rotated around like this. So what's this distance in this shell? Well, it's going to be just the right minus the left. And we're going to need to have things solved. All right, if we're using the shell method, square both sides. Exponentiate both sides. Okay, so the thing on the right is just the line y equals e. The thing on the left is this function. So shell is going to be 2 pi integral. It's going to be in terms of y. Y is going from 0 up to 1 of the y coordinate times that difference, which is the right-hand side is e, and the left-hand side is e to the y squared. dy. Doesn't look great, but it's doable. We distribute this y, and then we'd have a linear function, and the second one would turn into a u substitution. So it's not pretty, but it's doable. What about the disk method? Well, in the disk method, have things in terms of x. It's just going to be pi times the radius squared. Well, this seems kind of nice. Pi times, and x is going from 1 up to e. And the radius is the function value. This is going to be pi integral from 1 to e of just natural log of x dx. All right, and I think we briefly mentioned this integral with a formula. Technically, this uses integral by parts to get it, but I think I have a formula for you. So here I'd say the disk method works a little bit better, which is not what I was going for when I made this problem. Yeah, I think the disk method is the winner. Sadly. But there are some times where this is kind of a number 3. I said 2 questions. Well, sometimes it's also about what do you want to integrate. If you wanted to, you could add a number 3. That's not as common in this book, though. I just wanted to show you. But I guess in this case, they're both fine anyway. And then again, let me check my answer. These ones especially are a little weird. 2 pi integral from 0 to 1 of y times e plus e to the y squared. Did I type that in right? Oh, it's minus. Oh, that's just pi. That's interesting. If that's just pi, that means the area under this curve over here is just 1/2, which is kind of surprising and also interesting. Anyway, and the other one was just pi times the integral. X was going from 1 to e of the ln of x. Again, it is also, I think, kind of weird that this integral is just 1. But it is. So again, they are the same. Fascinating. There you go. So hopefully you've learned a little bit about what to watch out for when one method's better than the other method. It's always good practice to do both if you have the time. And it's also a great way to check your answer if you have the time in the scratch paper. Scratch paper is very useful. You don't have to include it on your work. Just off to the side, go, let's try this other method and see if we get the same thing. Now, it can backfire, of course, sometimes, because sometimes you'll make a mistake and then you'll be like, where's the mistake? And you might overthink, but I think most of the times it's good, especially if you feel pretty confident about this and are mostly just worried about finding small errors. So there we go. That's this video wrapping up the section. Hope you enjoyed the material. Bye-bye.